Week 14, lesson 4. Okay, so the first thing we need to talk about is the difference between a root and a factor. So let's just say you had this equation. Okay, and to solve this, you would factor out an x. And then you would set each factor equal to 0. Okay, so what I want you to see here is that at this point, these are factors, right? They are factors. It kind of looks, well, one of them especially looks like this, okay? But down here, we actually have roots. Sorry, not that one, this one. We have roots. They are definitely connected, right? One of them is more of the solution and one is sort of the way to get to the solution. All right, and so for this particular problem, we did it in this direction, okay? But the point of today's lesson, for the most part, is to do it in this direction. So if you are given the roots, can you go back and come up with the equation? Okay, so let's do this problem right here. Okay, so this is saying that these are the roots. That means I have x equals -1, I have x equals 1/2, and I have x equals the cube root of 3. Those are the roots. Okay, so this, as a factor, would have been x plus 1 equals 0, right? Which you can kind of easily see if you just move this to the other side. Okay. This, if I am trying to get it as a factor, right, is, well, let's see, I'm going to kind of manipulate it. If I multiply both sides by 2, I get 2x equals 1. And then if I subtract 1, 2x minus 1 equals 0. So now I have a factor. I have a factor. And likewise for the third one, if I cube both sides, x cubed would equal 3. And then move that to the other side, I get x cubed minus 3 equals 0. So there is my third factor. Okay, now, just because they're factored doesn't mean I now have a polynomial, right? I am supposed to be finding a polynomial. So I have to multiply all three of those together. So this one and this one are fairly easy to multiply together. You know how to FOIL. I'm just going to kind of do that fairly quickly. I'm going to get 2x squared plus x minus 1. And I need to multiply that by this remaining factor that I haven't used yet. So I'm going to do this sort of on a rectangle. I'm going to have x cubed minus 3. All right, so I'm going to kind of pause to fill these in like that. And then if there are any like terms, which there aren't, then I've got my whole answer here. So let me just sort of write it all out so you can see it. It is 2x to the 5th plus x to the 4th minus x to the 3rd minus 6x squared minus 3x plus 3 equals 0. Okay? It's supposed to be a polynomial equation, and I kind of wish this said that, and it's a little late for me to go back. However, polynomials don't necessarily have roots. Equations have roots. Okay, so scooting this up. Okay, so question here. First thing, I'm not sure why this printed this way, and I'm hoping that on yours, when you print it out, it doesn't look like this. But this 4 is actually an exponent, right? And this 3 is an exponent. Yeah, not sure why those didn't print correctly. But the way that I can tell if it's a factor is by using synthetic division, right? If this is supposed to be a factor, that means if I put 2 through synthetic division, I should get a remainder here of 0. And if I don't, then it's not a factor. Okay, so now up top, I need to put the coefficients that I'm finding here, which will be 3, -1, 0, right? Don't forget the placeholder, right? I don't have an x squared term, so I need to put a placeholder for it. 2, negative 24. Okay, so here we go. Bring the first number down. Multiply, giving you 6, and add. Multiply, giving you 10, and add. Multiply, giving you 20, and add. Multiply, giving you 44, and add, giving you 20. Since I don't have a 0, this is not a factor. Okay, if that had come out to be 0, then the answer would have been yes. Okay, so this one is asking you pretty much in essence to factor. Okay, but the factoring methods that you know, like trinomials, like difference in sum of cubes, like difference of squares, like GCF, the only one that's going to actually work here at the beginning is GCF, right? They all have an x in common. So x to the third minus 6x squared minus 19x plus 24. All right, but right now, the only factoring method that you know for 4 terms, right? Because this polynomial has 4 terms. The only one you know is grouping, and grouping doesn't work on this problem. Okay, so what we're going to do is we're going to use what we did in the last example, and we're going to see if we can find a factor using synthetic division. Okay, so I'm going to guess, right? Guess, and I'm going to try 1. Let's see if 1 comes out okay in synthetic division. Let's see if I get a remainder of 0. So I bring down the 1. 1 times 1 is 1. Adding, I get negative 5. Multiplying, I get negative 5, which gives me negative 24. Multiplying, I get negative 24, and adding, I get 0. Okay, which means, as far as linear factors, right now I have 2. I have this one that I originally factored out, and now because of this, I have x minus 1. I should have 4 by the time I'm done, and I know that because of that exponent. Right? The highest exponent is going to tell you how many linear factors you should have. So here, and I'm going to switch colors, here is my depressed polynomial. So the question is this factorable? And it is. It's factorable as x minus 8 times x plus 3. And now I have 4 linear factors. There they are. Okay, scooting this up. Let's try a next example. Okay, so this one, and again, you can read for yourself, but it says that negative 1 is a 0 of a polynomial with multiplicity of 3. That means that when I put negative 1 through synthetic division, it's going to work 3 times. Okay, it is going to work 3 times. So let's put it through at least once and see and prove that to ourselves. So here's the 2, the 7, the 3, the negative 13, negative 17, and negative 6. All right, so you bring the first number down, multiply and add, 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 and you get 0. Okay, so I can see that it works once. Okay, now it's saying that it's a multiplicity of 3, so I'm going to send negative 1 through again, but not through the original. Okay, I want you to sort of ignore those and send it through the depressed polynomial. So I'm sending it through these numbers. Okay, so here we go. Here's the negative 1. Bring down the number, multiply and add. Multiply and add, multiply and add, multiply and add. All right. Okay, so now I've sent it through twice. I need to send it through one more time. All right, and this time I'm sending it through these numbers, right? I'm sending it through the depressed. I'm trying to depress it again. So, oh, sorry about that. This should be -1. Okay, so I bring down the number, I multiply and I add, multiply and add, multiply and add. Okay, so again, all I've done right now is I've proven that it has a multiplicity of 3. It worked 3 times. Okay, so now I need to find, right, it wants it as a product of linear factors. So right now I've got plus 1 cubed. But there should still be 2 other factors, which I'm going to get from this depressed polynomial, right? 2x squared plus 1x minus 6, which factors to be 2x minus 3 times x plus 2, and then don't forget this is still part of your answer. There is my product of linear factors. Okay. Okay, this is looking slightly complicated, but what it's saying is if you end up with a complex zero, in other words, an imaginary solution, then you're guaranteed that you're going to have 2 imaginary solutions, and the other one is going to be the conjugate. Okay, so now that you know that, let's move this up and try this example. Okay, so it's not on the screen, but hopefully you have it in your notes. It says that 1 plus 3i is one of the roots. So because I know it is, I'm going to send it through synthetic division to depress it. So here's the coefficients: 1, -5, 16, and -30. Okay, and notice how I'm kind of spreading them out a little bit, and that's because it may need a little bit more room than usual. So you bring the first number down and you multiply, which gives you 1 plus 3i. Now when you add to what's up there, you have -4 plus 3i. Okay, so now when you multiply these two together, right? When you multiply these two together, that means you may have to FOIL. Okay, you may have to do that off in the margin somewhere. But I get, let's see. Okay, so the first term is -4, outer and inner. Outer is 3i, inner is -12, so -9i. And the last is 9i squared, which is -9. So this is actually -13 minus 9i. So when I add, I get 3 minus 9i. All right, and then I have to multiply. Okay, so again, you may have to FOIL that in your head, maybe in the margin, take your time. But when I FOIL that, I get 30. Okay, now notice I didn't write that out. I'm expecting you to actually do that. You should get 30. So now that it's depressed, let's send through the depressed polynomial, right? I'm sending through the complex conjugate of this. Okay, and the reason I'm doing that is since I am guaranteed that this works, I'm also guaranteed that this will work. So let's bring down the 1. When I multiply, I get 1 minus 3i. So when I add, I get -3, right? And then when I multiply, I get -3 plus 9i. And look at that, you get 0. I know, that one's a lot easier than the other one. All right, so that means my depressed polynomial here, since I've depressed it twice, is now x minus 3. Okay, so the third 0, x minus 3 equals 0, means my last 0 is 3. Okay, let me highlight these for you, all right, in green. Here's one of the roots that was given. The other, that is the complex conjugate, and I just realized that is not green. I do know my colors. And the third one is 3.